哎，可以了，OK。
Oh, hello. I'm here to show how to test a Peri pump before we go to the field site. So in this setup here, we've got a Peri pump, and we've got a battery that supplies 12 volt DC to the pump. We got a flow. This is the water quantity meter to measure in continuously the water coming out from the borehole. Here is the measurement chamber, and here is the water outlet. So we've got a water level here to measure how much water has been pumped. So once the water is full here, we put it to another separate bucket. So basically the bucket saves all the water coming out from the bowls. So now let's connect it. So here you can see we've got a rigid pipe that goes to the lower level, and the lower level has got a bucket with some water. So you can still see that there are some marks there. That is the indication of how deep the pipe has already been inserted to the bowls. So it goes all the way to the upper section, which looks like this. And here you've got a few transitions. So here is the rigid pipe, and it's connected to a flex pipe, so it's relatively soft. This one is relatively rigid. So the Peri pump will be squeezing this soft pipe continuously. So you can see this one tends to spin all the time. And the way how we insert it is to put it in right in the middle and ensure that the pipe is in between the teeth on both sides. So on the other side, you also have the same teeth. So ensure that it sits right in the middle, and then you just press it all the way down to ensure that it's inserted in right locations. Now, in terms of the configuration, so here we've got the speed control, the dim for speed control. So this is the flow direction. So currently we are moving from this direction to the other direction. So obviously we need to use reverse. And for the outlet, you will need to connect that to the water quantity chamber. So it has to be fed in from the very bottom. So the way how you insert it is that you try to push it all the way, and then give a pull so that it's sealed properly. Right? When you try to pull, then it's becoming very difficult. And the only way to be able to take this out is that you use your hands to fix the top ring, and then try to pull it out. So that's the only way to be able to pull it out. Ensure that it's been pulled out all the way so that it will be sealed properly. And once the water goes from the bottom, it will fill up the chamber and eventually lift from here. So this is the section. Now we connect another pipe in, and again it has to be squeezed all the way. And then pull out a little bit so that the pull out will reduce the diameter and then make a perfect seal. And it goes all the way to the tubing. Right? Now, we also need to install the sensors. So we've got the HANA water quantity measure. So we need to first unscrew the cap. And after it's being unscrewed, we need to ensure that the pH meter, the cap on the pH meter, is removed. And remember that the water there is to prevent the pH meter from being damaged. And after the test, we always need to fill that water and ensure that the pH meter is submerged. So we provide a solution here. So when the test is being finished, adding the particular water into that cap and then ensure that the sensor is submerged. And then you insert that into the chamber and twist it to ensure that the flow is able to be measured by the multimeter here it's a very important, useful thing is that I would advise to bring a table on the side, so you would have everything laid out in this manner, where you have the record paper ready and also pH meter ready. So we can switch on the pH meter right now by just pressing the power button, and then you will be able to see the welcome page, and then you just need to connect the measure. So just connect measure, and then you will be able to see some values there. So you can move up and down to change different values. Now let's switch on the pump. So again, before we start, speed control is somewhere right in the middle, and the direction is reversed through this way, and then we can switch on. So there are cases where the water flows very slowly or probably not moving at all. So in that case, we just need to ensure that this section between the rigid pipe and then the softer pipe is being connected properly, and we just switch it on. And hopefully we are able to identify some bubbles that moves along the tube. So currently it's air, so we can't see anything. And at this stage, we probably can speed up the Peri pump. So you will see the speed is being going up. So now it's maximum. So you can see the water is just moving along this way, and hopefully all the way from the water level in the pump, in the borehole, to the water sampler. So currently we are ready to receive water from the other side. Probably we just wait here. So I think the water is already coming to the quantities chamber, so that the water level is gradually rising up, and that means the seal in between is down perfectly, and there's low leaking at the very bottom. And we haven't tested the whether there's any leaking from this outlet, but nevertheless water is moving out. So here this one needs to be further tightened so there is no leaking at all. So now there's no leaking, and then you can see that from the outlet it's coming like a small stream, slowly fill up the container, and then we use this to identify how many liters has been received. Now let's look at how are we going to connect to record the results. So come over here. In this spreadsheet, we've got time. So when we do the measurements, we write down the time. And the still water level will be measured by a groundwater meter, which will be provided separately. So you just put it in slightly once it beeps. That's where the water level is. Record that. And the volume of water is measured by the container on the ground. In terms of EC here, so EC will be measured by, as you can see, this microsiemens per centimeter. So that's basically the EC. So currently it's 500, which means it's relatively fresh. The redox will be measured by the MVORP. So currently it's around 200, which means that it's very positive. It's not basically groundwater. Usually if it's groundwater, it tends to be a negative value. And we've got the dissolved oxygen, so that is 5.9. So this water is very well oxygenated. And usually if it's groundwater, we tended to receive some values very, very low. And we also got the EC with a star, so that's the effective EC. And this effective EC is the one underneath the EC, so that's EC with a star, so 510. That is the value we need to put it in. And in terms of temperature, if we just press down further, we got 23.23. So that will be filled in here. So the pH, finally it's a pH. So pH is 7.98. So we put it in here. Finally is, in general, what the color looks like. So you see that it's basically transparent. So you just say transparent. And then we just keep that doing. So once this line is finished, we do another line, probably in 2 minutes. So currently, how many liters we have received so far? So just within the time, we've already done 1,200 mils, right? Then the question is that how much do we need to pump water out? So first of all, let's do a quick sketch. Let's do a very quick sketch. So assuming we got a borehole, and here's the ground, and probably water level is here, right? And you slide in your tubing all the way to the location where your screens are. So let's say the screen is here. Now, usually we need to work out the volume within the PVC, and the amount of water to be sampled is basically 3 times of the volume we measured here. So this will be based on the specification of the borehole plus the current water level. But in practice, sometimes the borehole is very slow in responding. For example, in our site SA1, that is very slow in responding. So you will see, as long as this amount of water is being connected, the water going here is very slow. So in that case, we probably just connect whatever we have for the very last time. So if right now we connect the fresh groundwater, this is probably already oxygenated within the PVC tubing. So this means that this amount of water needs to go in here. But the final amount of water is basically coming out from the screen into the PVC, and that's basically the groundwater, not the water sitting within the PVC. So we just keep that going, and then finally we'll be able to fill up this spreadsheet, and then the sampling is completed. And when that is completed, the final amount of water needs to be filled into 2 separate samplers. So the bigger one is for anions, and the smaller ones is for cations. And for the cations, and we got 2 types. So one of them is the total metals. So in that case, we don't have to filter it. But if it's the just the dissolved ones, we need to filter it. So just use the syringe at the specific amount, and then inject it into the sample, sealed properly, and use the plastic, the electrical tube to seal it, and then we deliver for water sampling, and also ensure that the tube, the bottles are always in the cold conditions, in the free refrigerated condition. So if you stay in the hotel, it will be good to put it into the fridge, and then just send the whole thing for analysis. And once it's finished, you just switch off here, and then putting all the things in place. The most important thing is that once we unscrew the water quantity meter, the pH has to stay inside this rubber cap, and also filled with this solution to ensure that the next time the value is accurate. That's all about the trial today. So it seems to be working. Thank you.